Okay, so in this is a case where we've been given this figure and are trying to find the centroid of the whole figure, right? One way to do is that you consider this whole area to be a whole figure, right? And then you end up this are void, so you end up taking all these areas out, right? Taking all those areas out will give you the whole figure. So you have this, right? And then when you take this side off, you find the areas and you take this one, so it will give you the area of the one inside, like so. You end up getting the centroid of that one, right? So in order to find the centroid is actually, let's say, C, and then we have the S coordinate, right, and then the Y coordinate, and then these are the formulas for them, right? Because it's a composite figure, you find the area and then the S coordinate for each of them, you multiply, right? And then the down is the area, the same thing for the Y, right? So this is what we are doing. Looking at this one here, this particular diagram, you see that there are actually three sides. So this is what we do. To make our work easier, we could just name this big side, we could just term it 1, right? Area 1. So let's say, we're having three figures, right? So figure 1, 2, and then 3, right? And then let's decide to write our totals here. So this is what we do. So what we do is that we actually have to find the center coordinate for each of them, right, for the x and for the y, and then we find the area for each of them, and then what we do is multiply the area times the s coordinate, center coordinate for each of them, right, and the y center coordinate for each of them. So now figure 1 is this whole big figure. So figure 1 is big triangle, figure 2 is, let's consider the small circle inside, and figure 3 is the semicircle that we have this way. So I'll do something to show which one is a void and then which one is an actual shape. So looking at this one is a void, so like the shaded part, I'm just shading out to show that they are voids, but this one is a solid figure, right? So this is what we are doing. So figure A, right? Alright, so figure 1, right? So we are on this one. We are considering this whole big rectangle, right? It's actually a square. Yeah, so now to find the center for this one, because we are seeing this whole thing as a big figure, the center of for the s coordinate, right, in this direction with respect to the y axis will actually be just the center, right? In order to find that, it is just the whole distance here, which is from here to here, right, divided by 2. So when you add, this is actually what, 240. When you divide by 2, you get 120 for the x coordinate, right? The same thing, because from here to here, when you add this to 18 plus 160 plus 80 is actually the same 120 again, right? We are still on figure 1, which is this one, right? Yes. So then the area, I'm saying this because it's 120, because to get to the center of for the x side, right, here's 240. So to get to the center, it's actually just the 240 divided by 2. That'll give us what? 120. It's just the same thing here. You divide by 2 to get to the center. That's why we have 120 here, 120 here, right? Yes. And for the area is just the product of both of them, right? The product of the length and the breadth, or the length squared, which is 240 squared, right? 240 squared. Let's see. And actually using the table makes it easier. It makes your work faster because you have somewhere that you're writing all the data that you are getting. So it's way more easier that way. Let's see. Alright. So now to get the area is actually what, 240, right? 240 times 240. 240 times 240, right? Let's give that 57600, right? So let's see. Right, that's the area. And now to get this ax, you just multiply this by this, right? So let's just say, it seems it won't fit, so let's write it this way. 5700. So it's actually 6. Let's write it all. 57600, right? So 57600 Let's just multiply and see what we get. 57600 times this x, right? So what's x 120? 240 times 240. That's the area, right? Now doing this times x 120. So we're getting 6912 and then 3 zeros. Okay. Okay, so that'll be 66912 and then what? 1 2 3. Right. The same for the AY. The area just the same, so the values are the same. So 6912 1 2 3. Right. Now area 2. Meaning that we are done with this particular area. This one's R, right? We are done with that one. So now we are getting to area 2. Let me just use this. We are done with this one. So area 2, which is a this actual circle that's here, right? So for that one, now to get to the center of it, this is what we do. To get to the center of it, because looking at how the coordinate system is, this is y, right? This is x. Let me clean this so we can see this well. Always, because the coordinate system that is given is always the best practice to refer to a coordinate system. So this is origin, right? Per how it's been done, this is origin, right? This is x and then this y, right? So we do everything with respect to the origin. So we are moving from the origin, right? So here is like 0, 0, right? So we're moving from here to the center of the circle, right? So it will mean move from here to here. This has already been given, so we just 10, right? So to the center of figure 2, x is 10. Sorry. 100 rather. Right? Figure 2, the y coordinate, meaning what are we moving? We are moving perpendicular to x, right? So this have to be, it's actually been given from here to here, right? Which is the 18. Yes. Let's see. So now we need the area, right? Area is what? It's a circle, pi r square. So pi is pi times r. R is what? 60. 60 and then square, right? What do we get? 11309. Let's see if it fits. 11309.73, right? And then our AX, this will be times what? This is the area, right? Times 100. 1130973. So 1130973. Right. 1130973. Right. Yes. Our AY will just be this. Right. We have the A times Y, which is 18. Right. So let's see 18. So I get to 904. 77. Let me write this one. 778.68, right? Yes. And then the 3. Now we are done with this one, right? We go to figure 3. Where's figure 3? This is figure 3. Then again, we do everything with respect to what? The coordinate system, which is here as origin, right? So, in order for us to get to the center of that figure, when you understand this, no matter how the figure is, you'll be able to find the coordinates, the center of that particular part of it, right? But let me see something clear. We got to know that we actually classify them in 3, right? The composite figure, we grouped it in 3. And what we did was, we have area 1, 2, and then 3, right? And we said that 2 and then 3 are what? Empty spaces. So if the empty spaces, we actually have to take them out, right? So if we are taking them out, it means that the area is a negative area, right? So here is negative, here is negative. Sorry, it's a mistake. Meaning that area 2 is negative, right? And area 3 2 will be negative, right? Meaning that here is actually AX, right? Oh, stuff I want. There you guys get them back. Okay. So meaning that this area here, area 2 is negative, area 32 will be negative, right? Meaning that this AX here too is negative, and the one that will come here to will be negative, right? The negatives are very important because when you put them there, you don't have to think, you just have to add everything up and straight forward, right? So we are still on it. So this is what's happening. We're trying to find the second. Now we are down first and second. We are going to the third area, right? Which is this one, right? The third area, this. So now we are on this, right? So looking at this one here, in order for us to get to the origin, some of them we can look at the figures and see where the origin will be because of the geometry, but some of them you have to refer to data given, right? So that's a quadrant, right? 1/4 of a circle. So looking at this here, this is it. What it says is that in order to get to the center of a quadrant, this is actually the formula for the x coordinate and for the y coordinate, right? So now let's go. So let's write it down. That's 4r 1/3 pi, right? So let's see. When you get that particular part, well, irrespective of how the diagram is changed to get it right. So the center for the y, for the x, and the center for the y is the same. So 4r on 3 pi, right? So this is what we'll do. In order for us to get to the center of that particular one, right? You see, when we're there in that particular, how we're given the data, you can actually see that the center is down here, right? The center is down here. But in the one that we are actually trying to solve, the center is not the same way, but still the concept is the same, right? This formula is actually giving us where we find the center. This gives us where we find the center, right? So the center will be, if this is the origin of this particular figure, so now let's use this to see how it's happening. So if we turn what we saw at the other side, and let's say the origin is here, let's say here is here is y, and then here is the x, right? So the origin will be from here and then here, right? But we know for us to get to the origin, which is somewhere here, you have to move relative to the origin that we have in this particular diagram, right? So this is how the origin will be. Meaning that we have to move when we want to find the x part of it. For us to find the x part of it, which is figure 3, we have to move from the origin, right, and add something. So you see, from here to here, let's clear this up. Okay. Yes. Okay. So this is what's happening. From here to here, oh, I don't have a ruler, so bear with me. Let's see. So from here to here, you see, we said the whole thing as well. From here to here is actually 240, right? So if here to here is 120, then mean from here to here to is what 120 right? Yes. So in order for us to get the x part, we move actually 120 plus something, right? To find that one, there's a way to find it, but this is an easier way. We could actually use the full length, which is 240 here. Sorry. The full length, which is 240 here. The full length, which is 240 here, and then move back to come to the center. So it's like a subtraction. So we move from the origin to the full extent of it, which is 240, and then subtract back to come to the center, which is here, using the formula that was there, which is this one, right? So this is what we do. So 240, right, minus into bracket. What are we taking from it? Actually taking 4r on 3 pi, right? So that's what we do. Fraction. Okay, so 4, right? And the r is what? The r of that particular quadrant. Now our focus is here. Let's clean this out. Now we can see what's happening. So our focus is, let's see. Our focus is on this side, right? Now that I've shaded the blue, we know where we are. Minus times what? This is the formula r, right? The r is for 120, and then the down is for 3 pi, right? So this is what we are getting for the the x coordinate of the figure 3, which is the quadrant, the quarter of the circle that we are doing. So 189.07, right? And then looking at it again, Now to get for the y's is the same thing. Why is it the same thing? Because let's do this again. The radius is from here to here, which is the same thing. Let me use another color. So the radius from here to here, 120, from here to here is 120. And since all of here is 240, we take this 120 out, we move from here, we are moving the direction of y, right? So from here to here is the 120, right? 120 plus that formula that gives us to get to the center. Then again, we can still do the same thing. We just move to the full extent. Let's see. We just move to the full extent, which is from here to here, right? Which is 240. Sorry, 240. We're just doing the same thing. Minus, so we move to 240, and then use this formula here to bring us to the center, which is a minus, right? So just bring us to the center, right? So 240, just the same thing. So the formula for both of them is the same, right? So we end up getting actually the same answer, which is 1, which is on the color, which is 189.07. I don't want to claim that negative there because we said it's important. So 189.07. Here's negative, right? And now to get the area is actually what? The area of a circle divided by 4. So how would that be? So that's this way. Let's see. Divided by 4. And the area of a circle is pi r squared, right? So pi times r squared. For that semicircle, the radius is what? 120, right? So 120 squared, right? So this is what I get. 1130.973. Let's write that. It seems to be the same as this. 1130.973. I want to write this out well. I'll see what's actually happening. One 9.73, right? Negative, but here too is negative, right? So what are we doing here now? We are now trying to find the area, right? So a times x, right? So this answer that we are having times, what's the x that we are having? Sorry. This is what we had. Times what? X, 189.07. 189.07. That we get to 2183, blah blah blah. So let's write it down. 2138 331.3, right? And then our AY, because the area is a negative area, right? Meaning that the AY to be negative for both of them, right? So then the AY will be, there's A, there's the Y. Seems to be the same thing. So let's see. 2, sorry, the same figure. So this is our A, this is our Y. To be the same thing as the A and then the X, right? So 2138.331.3. Right. Here's AY, this is A, this is Y. Wait, this is A, this is Y. Okay, so now let's move on. Now that we have all this figure, this is what we do. We add up what we actually need to find the total thing, as we said earlier. To find the X and then the Y. It's just the sum of this, which is AX, right? So we have to find here. We need to find what's here, right? Which is AY. And then we need to find the, AX, and then we need to find AY. And then the area, which is this one. So these three is what we need. What we need. Let's move on. Find the area. So let's see. So that's 57600, right? Minus 2 in bracket. Yeah. 113. 09.73, right? So we have this for the area. So 34986.54. I'm just writing it down because I can't find it somewhere. Let me write it there. 34986.54, right? That's for A. And now we are we need A, we need this and then this, right? So let's see. So for the AX, we are adding them up. So we have 691.2.23, right? Minus the sum of these two, this and this, just 1130973, right? Yes. And then plus this one, which is 2138, right? 331.3, right? So that's what we are getting this side. 3642 points. Sorry. 3642695. 642.695.7, right? And now we come to AY. What do you have for that one? Yep, 691.230, right? This one is negative, right? This AY here is negative, so minus 904.778. Something missing. It's showing a dot somewhere. Okay. Minus 2138. 331.3. That's what I get in. 3871890.7. Now that we are here, the only thing we have to do is just to put them here and then find our answer, right? So to find this one, now we're trying to find the x, right? That's what we are doing now. So this ax here as well as here, right? So let's see. And this area here is this area here. So the sum of the areas. So we end up getting some of this sort. Ax is 3642.695.7, right? And then the area, which is 34986.554, right? What are we getting? 104 point what? Let's say 2 decimal places, 0.12, right? And then please let's remember the unit, right? The unit of, it's always important to bring this is 1 millimeters, this is 1 millimeters, this is 1 millimeters squared, and this is 1 millimeters cube, this is 1 millimeters cube. So millimeter cube divided by millimeter squared will give us 1 millimeter, right? Yes. So let's remember the unit, very important. And then the AY, to find this y, the area down is the same. Let's change just the top. What do we need there? So AY, which is this one, that's 38 7189 and what 0.7, right? And that's giving us what 110.6 millimeters. Yes. Whatever that you do, so in as much as you're on the right path, you should get an answer close to this, depending on the decimals and stuff that you have. But the first three numbers should be close to this, right? Yes. So this is how it is. Use the data, remember the principles and the formulas that you need to use per data given, and then yeah, we'll be fine. All right.